will be having 9 chapters, and yesterday we have gone through 2 chapters, and now we'll go with the rest of the chapters. Okay, today we'll be having physics lessons. Just I'll be connecting the video. Just wait for a second. Okay, Porbandar Plan Diary has entered the session. Okay, thanks for your visit. And nowadays I'm in school, not able to attend the responses. Sorry for not attending the responses because I'm in school. Okay, thanks for your visit. Thank you. Okay, everybody look at the lessons. Okay, yesterday we had completed the lesson on motion, force and laws of motion, and today we'll move on to the chapter gravitation. Try to note down important points.
Chapter 10, Gravitation. Gravitation. Earlier in the previous class, you have learned that the simplest type of motion along a curved path is uniform circular motion. In circular motions, centripetal force is applied by the same agent. Goes round the earth and the planets go round the sun. Apart from formulating the 3 laws of motion, Sir Isaac Newton examined the motion of the celestial bodies, the planets and the moon. He investigated the nature of force that keeps the moon in nearly circular orbit around the earth. Newton's laws of gravitation. Newton concluded that every object on the surface of the earth is attracted by the earth towards its center. He also showed that the force exerted by the earth on an object varies inversely as the square of its distance from the center of the earth and directly as the mass of the object. This led Newton to generalize that there is a force between any 2 objects and to propose his law of gravitation. Every particle in the universe attracts every other particle with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. This force acts along the line joining the 2 particles. If M1 and M2 are the masses of 2 bodies separated by a distance d, then the gravitational force of attraction F between them is given by F proportional to M1 and 2, again proportional to 1 upon d square. F is proportional to M1 M2 upon d square. F is equal to capital G M1 M2 upon d square, where G is called universal gravitation constant. G is equal to 6.67 into 10 power minus 11 Newton meter square kg square. Important features of law of gravitation. Gravitational attractive force between two bodies is independent of intervening medium. It is not affected by any change in temperature, pressure, or any other physical condition. This law holds good not only for bodies on the earth but also for heavenly bodies which are at a greater distances like planets, natural satellites, stars, galaxies, etc. Hence, the law of gravitation is a universal law. Acceleration due to gravity. The gravitational force of attraction between the earth and the material bodies is normally called gravity. Consider a body of mass m on the surface of the earth. The gravitational force exerted by earth on this body is called weight of the body and is given by W is equal to F, that is equal to mg, where g is the acceleration due to gravity at the earth's surface. According to Newton's law of gravitation, the force between the earth and the body is given by F is equal to G_m_e into m upon r square e. Me is equal to mass of the earth, Re is equal to radius of the earth. Comparing equations 1 and 2, we have W is equal to F. Mg is equal to G_m_e into m upon Re squared. Therefore, G is equal to G_m_e upon R squared E. Variation of G. Mu of G on the surface of the earth is G is equal to G_m_e upon R squared E. If the body is at a height of h above the ground, then the acceleration due to gravity is given by G dash is equal to G_m_e upon Re plus h whole square. From equations 3 and 4, G dash is equal to G into 1 minus 2h upon Re. Following points can be revealed from the above equation. Value of G is independent of mass of the object. It depends on mass and radius of the earth. With altitude, acceleration due to gravity decreases.
If the body is at a height of small h above the earth's surface, then acceleration due to gravity at that point is given by small g dash is equal to capital G into capital M-E divided by capital R-E plus small h whole square. With altitude, acceleration due to gravity decreases.
G at various altitudes. Variation of G with depth. Value of acceleration due to gravity at depth h meters from the earth's surface is given by G dash is equal to G into 1 minus h upon Re, where G is equal to value of acceleration due to gravity on Earth's surface. Re is equal to radius of the Earth, h is equal to depth. The above equation shows that the acceleration due to gravity decreases with depth. Variation of G with latitude. Since Earth is an elliptical shape, as we go from equator to polar region, G increases. G is higher at the poles rather at the equator.
Okay, this completes the chapter Gravitation. Now next, we'll move on to the next chapter, Work and Energy.
Chapter 11, Work and Energy. Work. Work is said to be done by a force if the body on which it acts is displaced in the direction of the applied force. Work is done on a body by an external agency. To do work, that external agency must have energy. For example, 1. Without muscular energy, can a person push or pull or hit an object? 2. Can a rocket move up without fuel? 3. Can the railway engine pull the bogies without energy? 4. Can cricket ball move towards the boundary without a hit? On doing work on a body, it gains energy. Hence, in the process of doing work, energy is transferred from external agency to a body on which it exerts force. In physics, work is said done only if the body displaces in the direction of the force. The amount of work done, W, depends on two factors. 1. Force, F, and 2. Displacement, S, in the direction of the force. It is given by dot product of vectors F and S. Work equals F cross S. Work equals F dot S equals vector F multiplied by vector S into cos theta, where 0 is the angle between vectors F and S. Both F and S are vectors, but work done is a scalar. Special case. For a body moving along a straight line under the action of force, the work done, W, is by the product of magnitude of force and distance travelled along the straight line. W equals F cross S. SI unit of work done is joule. Energy. Energy is the capacity to do work. SI unit, joule. Principle of conservation energy. Energy can be transformed from one form to another form, but the total energy remains constant. Different forms of mechanical energy are given below. 1. Kinetic energy. 2. Potential energy. Kinetic energy. Kinetic energy of a body is the energy possessed by the body by virtue of its motion. Work done by force equals F equals ma. Work done against the force equals minus F equals minus ma, where A equals minus u square divided by 2F. F equals minus of minus m into u square s divided by 2f. Kinetic energy of the body equals mu square divided by 2. If v is said to be the initial velocity, ke equals mv square divided by 2. Potential energy of objects is at rest due to their position or state possess capacity to do work. SI unit, joule. F equals mg. Work done equals force into height is equal to mgh. Potential energy is equal to mgh. Law of conservation of energy. Energy can neither be created nor destroyed, but it can be converted from one form to another form. At A, entire energy is potential and is equal to mgh. Ke equals 0. Total energy equals Pe plus Ke equals mgh plus 0 equals mgh 1. At B, velocity increases and reaches maximum. During this, Bob has travelled distance of x. V square equals u square plus 2as. V square equals 0 plus 2gx. V square equals 2gx.
Simple pendulum. Consider a simple pendulum oscillating about its mean position.
the mean position, it has maximum kinetic energy, but no potential energy. When pendulum crosses the mean position, its potential energy increases and kinetic energy decreases. At the extreme position, it has maximum potential energy, but no kinetic energy. When it moves towards mean position, potential energy decreases and kinetic energy increases. At any given position, the sum of the kinetic and potential energies always remains the same. Hence, we can say that the total energy remains constant, that is, the energy is conserved.
Kinetic energy at B equals half mv squared. Half m into 2gx equals mgx A. Potential energy at B equals mgh equals mg into h minus x B. Form A and B. Total energy equals potential energy plus kinetic energy. That equals mg into h minus x plus mgx equals mgh minus mgx plus mgx equals mgh 2. Power. Rate of doing work is known as power. Power equals work done divided by time. P equals W divided by T. SI unit, watt, W. Following units of power which are in use. 1 kilowatt equals 1000 watt. 1 megawatt equals 10 to the power of 6 watt. 1 gigawatt equals 10 to the power of 9 watt. 1 terawatt equals 10 to the power of 12 watt. 1 kilowatt hour equals 3.6 into 10 to the power of 6 joule equals 3.6 megajoule.
Okay, this completes the lesson on work and energy, and we'll move on to the next chapter, last chapter in physics, sound. And I would like to tell for students, please don't exit the class, watch the class completely and try to note down the important points.
Chapter 12, Sound. Sound. We hear many sounds, some very pleasing, a few of them noisy, and a few of them very faint. We hear some sounds. Anyone hear some other sounds? And doctors use for internal investigations like ultrasonic scanning, etc. Bats use this for navigation. Sound is an important part in our community. We as human beings produce sound. The level of sound, the category of sound, makes us to respond differently. Let us try to know more about the same. What is sound? Sound is a form of energy. It can be converted from one form to other. This is exactly what happens when a principal speaks in front of a microphone and you hear at a distance from a loudspeaker. It is used to communicate for scientific experiments, medical investigation, navigation, distance measured by submarines, and many other applications. Vibration of paper in front of a speaker, dancing of thermocol balls on a drum surface when hit, etc. show that it is a form of energy. How is sound produced? Let us look at some examples. Vibration of strings of guitar, veena, sitar produces sound. Vibration of surface of drum produces sound. Blow air into a trumpet. Burst of blown up balloons produces a big sound, etc. As we know, vibrating bodies produce sound. In human beings also, The vibration of membranes with a voice box called larynx produces sound. Sound propagation. Propagation of sound needs a medium. When you hear the sound from your computer or laptop speaker to your ear, it is the air in between which acts as a medium. It propagates in the form of waves. This is similar to when we drop a stone in still water. We see waves spreading across all directions. To show that medium is required for propagation, let us do bell jar experiment. Here, a bell is placed within an airtight jar. We hear the sound of bell. We also have connected a vacuum pump to suck out air from the jar. When air is sucked, even though when we press this button, we do not hear the sound of bell. Repeat this experiment. You can conclude that medium is required for sound propagation. Speed of sound. We have observed the difference in the timing when we see lightning in the sky and when we hear the thunder. There is time difference. Actually, both happen simultaneously. It is due to the difference in the speed of light and speed of sound. We hear the thunder a bit late and observe the lightning earlier. As we know, light travels at the speed of 3 into 10 raised to 8 meters per second. Sound travels at approximately 350 meters per second. This is equivalent of 1260 kilometers per hour. We hear the fighter jet planes traveling at Mach 1. This is equivalent of almost 340 meters per second or near to the speed of sound. This translates to 1225 kilometers per hour. In general, the commercial airlines travel around 800 kilometers per hour. Speed of sound is dependent on wavelength, frequency, medium, temperature, etc. It is faster in solids than liquids than gases. Properties of sound. Let us try to know more about wavelength and frequency. When the body vibrates in a repetitive manner, it creates waves. Take a look at the wave here. It has crests or valleys and troughs or peaks. The distance between two crests or troughs is called wavelength. It is represented by this sign and is expressed in meters. We can see many waveforms with different wavelengths. The transverse waves also have amplitude. It is the maximum displacement from the mean position. The number of repetitive waveforms per second is called frequency or number of oscillations per second. Let us look at different waveforms with different frequency. We see 10 waves passing within a second, 20 waves passing within a second, etc. This is nothing but frequency expressed in unit called hertz, indicated as Hz. Human beings can hear between 20 Hz to 20,000 Hz or 20 kilohertz. This is called audible range. Below 20 Hz is infrasonic and about 20 kilohertz is ultrasonic. Speed of sound is represented as wavelength into frequency. Let us study important properties of sound. Reflection. The sound waves also get reflected. We observe this in an empty room and also when we hear an echo. For an echo to be heard, the sound waves have to reach ear after a gap of 0.1 second from the first sound heard. This is used effectively in auditoriums, cinema halls, etc. Let us recall some of the properties of sound studied earlier. Sound is a form of energy. Sound is produced by vibration of bodies. Sound is propagated in the form of waves. Sound requires a material medium for its propagation. Speed of sound is less than that of light. Speed of sound in air is about 330 meters per second. It has higher speeds in liquids and solids. Sound just as light undergoes reflection. Echo is due to reflection of sound. Introduction. We know that sound is produced by vibrating bodies. Sound waves reach our ears by traveling through air. Due to elastic nature, particles of the material medium around the vibrating body are also set in periodic vibrations. Gradually, periodic disturbance propagates in the medium, forming sound waves. Human ear responds to the sound waves of frequency 20 Hz to 20,000 Hz. This range of frequencies is called audible range. Sound waves of frequency less than 20 Hz are called infrasonic, and sound waves of frequency more than 20,000 Hz are called ultrasonic waves. Ultrasonic sound. Sounds of frequency beyond 20 Hz are called ultrasonic sounds. The range of ultrasonic sounds is from 20 Hz to 5 into 10 raised to 5 kilohertz. The range of wavelengths is from 1.65 centimeter to about 6 into 10 raised to minus 5 centimeter. Properties. 1. Ultrasonic waves are longitudinal waves. 2. Propagation is similar to that of audible sound. 3. These travel with the velocity of sound. 4. Energy of ultrasonic waves is high due to its high frequency. 5. The range of wavelength is from 1.65 centimeter to 6 into 10 raised to minus 5 centimeter. Production of ultrasonic waves. Ultrasonic waves can be produced by 1. Gatling's whistle experiment. 2. Magnetostriction oscillator. 3. Piezoelectric oscillator. Uses of ultrasonic waves. 1. Ultrasonic waves are used in bloodless surgery. 2. Used to detect flows in metal blocks and also to find the level of liquid in a metal tank. 3. Soft internal tissues of liver and spleen can be seen clearly by ultrasonic waves. 4. They are used in dry cleaning of clothes. 5. They are used to cure pneumatic paints. 6. They are used for welding and drilling small holes in hard materials. 7. They are used to manufacture emulsion for photographic films. 8. They are used in sonar. Sonar, the acronym stands for Sound Navigation and Ranging. Sonar is a device that uses ultrasonic waves to measure the distance, direction, and speed of underwater objects. Construction and working. Sonar consists of transmitter and a detector. Transmitter is one which transmits ultrasonic waves. They travel through water until they strike on an object. After reflection, reflected waves are detected by the detector. In the detector, sound energy converts into electrical signals. The time interval between transmission and reception is recorded T seconds. If v is the velocity of ultrasonic waves in water, then distance d of the object is d equal to vt by 2. Sonar technique is also used to determine the depth of the sea. Ultrasound Scanner. Ultrasound Scanner is an instrument which uses ultrasonic waves for getting images of internal organs of human body. This finds application in the field of medicine. We are very familiar with the medical terms ECG, echocardiographer. ECG is used in the diagnosis of heart diseases. Nowadays, ultrasonic scanner has become a good diagnostic tool for examining the bladders, kidneys, and also to know the factors during pregnancy.
Nowadays, ultrasound scanner has become a good diagnostic tool for examining the bladders and kidneys.
Human ears. These are the sense organs meant for hearing and maintenance of body balance. The ear is divided into three parts: the outer ear, the middle ear, and the inner ear. The inner ear is enclosed in a bony cavity of the skull. The outer ear consists of pinna, auditory canal, and the tympanic membrane. The pinna is made up of cartilaginous tissue covered with skin. It collects the sound waves and allows into the auditory canal. The wax produced in the outer ear helps in checking foreign bodies. At the end of the auditory canal, there is a thin membrane called as tympanum or eardrum. When sound wave strikes the tympanum, it vibrates. Middle ear. It consists of three small bones called magus, hammer, incus, angle, and sternum. The sternum is close to the oval window or fenestra oval. The vibrations of tympanum move to the inner ear through the movement of these three bones. The middle ear is connected to the throat by an air passage called eustachian tube, which equalizes the pressure on the two sides of the eardrum. Inner ear. It is surrounded by a fluid called perilymph. The inner ear has mainly two parts, utriculus or sulculus. The upper part is the utriculus connected to three semicircular canals. The lower part is the sulculus, which has an appendage called as cochlea. The entire ear is filled with a fluid called endolymph. The function of utriculus and semicircular cavities that it maintains the balance of the body. The cochlea encloses a delicate structure called organ of Corti. The receptors present in the organs of Corti join to form the auditory nerve. Mechanism of hearing. The sound waves that enters the pinna makes the eardrum to vibrate. These vibrations are carried to the inner ear to the chain of bones in the middle ear. The vibrations are further conducted to the organs of Corti through perilymph and lymph. These wave impulses are picked by the auditory nerves to the cerebrum, which interprets the sound.
Okay, now, till now, we completed the chapters on physics, the motion, force and laws of motion, gravitation, work and energy, and the last chapter, sound. We completed physics. Tomorrow we'll be having the class on chemistry. So don't miss the class, and this is the bridge course related to the 9th standard. Please go through the video link, take down important points and get ready for pre-test and post-test. Tomorrow we'll be having the classes related to the chemistry. Thank you for your visit and watching the video, and be serious about the classes and get ready for pre-test and post-test. Thank you one and all.